It's now recording officially. Okay, so we start, guys. Can you see my first slide? The first slide?
Yes, we do.
Great. So welcome to the virtual IETF 107 role interim meeting. We are happy that you are here. Please be aware that this meeting is aligned with NoteWell. Read carefully. They're not going to read it here. Our meeting materials. Please put your name and affiliation into the Etherpad. Is the link there. Okay, we have the slides as well, and the Java. Michael is there. Pascal, send the link into the mailing list. Sorry for not putting here. It's role@java.itf.org, and as well in the Etherpad is the information how to you can create a link, an account, and install the client. So it would be nice if you can volunteer for minus taker, or I will watch. We'll be watching the Java here. Okay, this is our agenda. So we are going to have first Pascal.
Ines?
Yes.
I don't see the slides anymore. How about others?
You don't see the slides?
Me neither.
Me neither.
Projecting.
You're not sharing anymore
Okay.
or something?
Sorry. Let's see. Oh, wait. Yes. Para share application. Okay, wait. Slides. Hello. Now?
Yep.
Okay. And now?
Yes, full screen.
Yes.
Thank you.
Thank you. Sorry. Yes, I got disconnected because it's beta for I am Ubuntu. They say that it's beta sharing. So sorry. So this is our agenda. So we have Pascal first explaining the updates in unaware list, then Raul the updates in PDAO related with the Ripple status, then Pascal talking about which is about the cluster that is dealing with a lot of documents. Then Raul is going to explain the updates in capabilities and MOPEX. Then Aris is going to explain us the updates in NC extension. Then Raul is going to give us the Ripple observation. Then we are going to go to a new document, these modification use cases. That's very important to address the modification IETF document. Then Michael will give us update enrollment priority, and Pascal will introduce again the LIDI information new document. Some comments about the agenda? No? Okay, we continue. Okay, we have...
remind everybody that the timing is quite short. 10 minutes is quite short, so make your presentation concise and to the point.
Yeah. So we have our milestones. We have 3 milestones done so far. So we have submitted to the ISG turn on 8138 and the unaware leaf. And as well, we already have the Notepad DAO. About the use of Ripple Info, we are with the last updates, and the version 39 should be soon ready for shipping. But yeah, we are correcting some reviews. So which are the status of our internet draft? So how you see, we are going to have a lot of this today discussion. I will say 2 of them are in the ISG. And there are some others that they are standby. From the related internet draft, we are going to have 2 of them today. So we have, thank you very much to everyone that opened the tickets. So we have documents. We have opened this because until the, finalized, I think it's fine to have it open. Ripple status code 130 is already changed to 195. So then we have some for Ripple observations and from the capabilities. As well, we have for, enrollment priority probably they are fixed now. Have to check that, and then the DAO projection. We have some old tickets that we keep in both systems, but with priority in the GitHub. That is just for anyone to look at that. They can see as well into the IETF tool. Okay, so we have kind of connections for the documents. So we have the Ripple observation state which issues should be worked on. Then capability draft have a lot of connection with different documents with the leading information. With MOPEX, they state that are mutually exclusive, so therefore we have separated both documents. As well, they propose a capability indicator to support syslog RH, and the RML priority mentioned as well the capability draft that maybe could be implemented like that. The capability draft, got disconnected with the project DAO. Then we have legendary information related with this modification that modify the disk-based object, and as well related with the use cases. And unaware leave, it's a live use of Ripple info, and as well with efficient MPDAO. Okay, Pascal, please.
So yeah, hello, I'm just starting the video because I'm talking, but if somebody has bandwidth issues, please let me know and I will stop the video. Did you make me the presenter?
No, I will, sorry, we don't mention, you just have to tell me next, and I will, so we save more time like that.
Okay, so next, please. So there was a lot of effort between IETF 106 and IETF 107 on the Ripple unaware draft, and there are reasons for that. One big reason is that the unaware draft is the last draft in order. There was the least progress draft holding cluster 310. So I will tell you later about cluster 310 and you'll see why. The other thing is there is actual demand from the field about providing the unaware leaf because people sense that the low power devices at the edge of the network that don't participate to Ripple would spend a lot of energy if they would have to use Ripple. So enabling just the RFC 8505 as the interface to the Ripple router and removing Ripple from the edge device, from the low power leaf, that is actually very useful in the field. So there is demand for that. Last but not least, 8505 is used as the host to router interface in a number of drafts, actually. It's used, It's used by Ripple, it's used with unaware leaf, it's used by Rift. It's also used in the backbone router draft to trigger proxy operation. So it's a useful feature, but there was no draft which really explained for any of them fine-grained details. So it's a good example for somebody who wants to implement the equivalent function in Rift, for instance. So we progressed a lot, went through work group last call, and now Ines has just submitted the document to the for submission to the ASG. And so next slide, please. So what went in? Well, if you make the diff across all the versions, all the steps we made since last IETF, there are many editorials and small changes. So I didn't go through the long list. I just picked the most important changes. So for one, we did improve quite a lot the description of how RFC 8505 works, and we did that to explain how that matches, because 8505 is the host behavior, how that matches the router behavior that we have in this RFC. There was also a lot of work with Ines and Michael on use of Ripple info and all the flows, and you'll see that some of my slides after this are about that. And so we synchronized the two specifications, decided the normative relationship between the two. And so we ended up with this doc having a normative reference to use of Ripple info and placing in use of Ripple info the text about external routes. And the Ripple unaware leaf is a form of external route. It's a host external route. So we also included text about the minimum functionality that needs to be supported by the rule to be able to qualify as a rule and be usable in this draft. Even though we document the router behavior, there is still dependency on the host behavior. In particular, being IPv6 compliant for the way it consumes a hub header as a host, and the way it ignores a source route header that is actually consumed. So we also added text on 6CIO since we use it. It's just descriptive because it's the behavior, the background that is needed for this draft. So we don't change RFC 7400, but we show how it plays in this story. And we also added a flag, and that's important one in the repo config, to option to be able to signal that the root will do the EDAC exchange with the repo with this LDR. So you can actually save this packet across the network. So the periodic EDAC exchange that refreshes the state at the 6 EDR is actually proxied by the root. So you don't have two packets, the DAO and then the EDAR that goes all through the network. And that's again because we want to save power. So there was Raul's request to actually document the termination flows. So we have that. Like I said, many editorials. Next slide, please. Okay, so I don't know if we have time. The chairs tell me what I did here is across like the 4 or 5 next slides. I provided illustrations on the headers that have to be inserted in case of a REPL unaware leaf. If you have time, if we have time, then we can spend the 5 minutes. If we don't have time, then please save that. That can be useful.
We can have, I think, 5 minutes to explain.
Okay. So the first slide is about the storing mode overhead, and that's for any REPL aware node. And we see that if we have a packet coming from the internet, typically what happens is you have to encapsulate IP in IP because we insert the RPI. And since we don't actually insert, we have to encapsulate. So to be able to add the RPI to the packet, a packet coming from the internet will have this RPI. So it's kind of typical inside a REPL network to do some encapsulation. Next slide, please. And in non-storing, we have more information to add in the outer header because we have to put the source route path. And I've indicated the case here of this node 56, for which we have to add not only the RPI, but the source route info. Next. And it's just to be able to compare the typical routing stretch for in storing mode for REPL aware node would be that the packet have to go to the common parent. Since the node is REPL aware, it will put an RPI in the packet. So the common parent will just forward in this case, will just forward the packet down. Now, if the packet is coming from the root, then the root also inserts an RPI, and that's the thing that you see on the bottom right. So this is very typical. I don't want to spend time on that. This is the traditional RPI being in the packet. Next. Okay, and in non-storing mode, as you know, we have to go all the way to the common parent. So even if the source is REPL aware and the destination is REPL aware, so the source sends the packet with the RPI as usual, but the packet will follow the default route all the way to the root because there is no better route inside the network. So it will go above parent 22 all the way to the root. The root will tunnel the packet, so it will have to encapsulate the packet even if it's coming from inside the REPL domain. And you see the difference. Now we have this double encapsulation and double RPI. I hope it's clear. Then again, there is nothing new to the rule. It's just the way REPL works. But just to be clear, that's the situation we have today. Mm-hmm. Next. And yes, there is this alternate possibility where the source, which is a RAN, instead of placing the RPI straight in the packet, uses an encapsulation to the root. And he may do that. That doesn't make the path longer. The difference is that the root can remove the outer header, so it removes the RPI. So at the root, we get the packet, which is just source 51, destination 52, and stuff, which is the content of the packet, but the RPI is gone, which means that the packet on the way up is bigger, but the packet on the way down is smaller, basically. So using the format on the left is what the RAN can do. If it wants to send a packet to the internet and it wants to make sure that the RPI will not fly, there, now that we use 23, it's not needed because normally the internet will ignore the RPI. Next. Okay, and there goes the new discussion, and these are the slides which are new, and I hope, Ines, check with me, please, but I hope I was correct. So we start from a packet which is generated by a rule, which is 51. So 51 is not aware of ripple, so by definition there is no RPI. So it just sends this packet 51 to whatever destination. It doesn't matter really. And so the first 6LR, the first operator 41, will have to encapsulate this packet to be able to insert an RPI. And as it goes, the packet always goes to the root. So it will encapsulate source 41, destination root, RPI, and then you get your packet. If when the packet reaches the root, then the root will decapsulate, and that's the thing that you see on the top right. Source 51, destination internet stuff. So if the packet goes to the internet, fine, that's exactly what you expect on the internet, there's no RPI. And if, on the other hand, the packet is for a destination, which is like 56 on the bottom right, then the root will have to encapsulate. So we're I gave just illustration in case of storing mode. That will be the source root, destination not 56, because it's a RAN, and an RPI, and then the encapsulated packet. So I just gave one example of going down in the case of a RAN, and that's what you would get. Next slide, please. Okay, so now if the destination is a rule, so the way up is exactly as we said. I'm not doing it again. I'm just focusing on the rightmost piece now. And they have two cases of packet, and the packet can be, for instance, coming from the internet. So that's the thing you see on the top. So you get a source internet destination 56 and whatever content. And you see that the root will encapsulate destination, the 6LR that serves the not 56, because 56 is a rule. So remember, we are using non-storage mode signaling for external routes, meaning that the root knows the parent of 56, and that's 46. So the root will turn on to 46 to add the RPI. That's true if the packet comes from the internet. That's true if the packet comes from the rule. And as we saw, it's also true if the packet comes from the rule on the bottom left, because it would have been encapsulated by 41 to the root, and the root would have decapsulated it. So in any case, if it's coming from a rule, from the internet, or from the root, we end up with the plain packet that has to be encapsulated with an RPI to the parent, to 46. Okay, next. So in storing mode, it doesn't make any difference because the route to 56 is not known to the network. So following the default route to the command parent gives you all the way to the root anyway. So whether the source is a RAN or the source is a rule, the packet will always reach the root. If the source is a rule, then we saw that the parent 41 would have encapsulated to the root anyway. But if the source is a RAN, like for instance illustrated on the left, well, it's not even what's illustrated. We really don't care. The packet will reach the root anyway. So what the root gets is a packet with possibly an RPI if it was coming from a RAN, but also otherwise it's a plain packet to Mr. 56. So if the root is the one injecting the packet, then it may avoid encapsulation, and that's, I guess, illustrated here. In this case, it may decide to use source route header to the parent as opposed to using an encapsulation to the parent, if it is the source of the packet. If the source of the packet is something else, then that cannot happen. But I guess what I really wanted to illustrate with this slide is the root is the source. It has this alternate capability, this alternate possibility instead of encapsulating to 46, to just say next stop 46, and in the routing header of 56. And then what's going to happen is 46 will receive the packet, see that there is a routing header, swap the destination IP and the routing header, consume the routing header, forward the packet to 56. And that's the case where 56 will have to ignore a consumed routing. Next slide. So this is the more normal. So I'm just surprised that this slide comes after the other because it should have been before. So I just swapped them somehow. So this is the most normal case for a non-storing mode to a rule. So the packet is whether it's coming from the internet or coming from the root in most cases, or even from the network. Anyway, reaches the root. Anyway, the root decapsulates it if it was encapsulated from the inside, or just it's a plain packet from the internet. And the root will have to encapsulate the packet to the parent. And since we are in non-storing, then there will be all the intermediate hops. I give you one format, which is the black source root destination 46. See that it doesn't really matter if the inner packet is the one from the root, from the internet, or from 51, which was a rule in this case. You see that at the end of the day, the root has this packet, which is those three elements, and it's all encapsulated. And the way it arrives, so what you see illustrated with this big ladder is what 46 sees. So what 46 sees is a packet where 35 has done the swap. So 35 is the last consumed entry in the routing header. 46 is the destination. So 46 gets a packet for which the external header is fully consumed. The external routing header is fully consumed. It is the destination. So it will decapsulate. And the inner packet, which is the original packet, regardless of its destination, will reach 56. So in this case, you see that 56 gets a clean packet without an RPI. The only case where there would be an RPI is the case of a source inside the network, which is a RAN. Otherwise, the packet is clean. So if the source is a RAN, so there's an RPI, and that's why we have to mention that a rule must ignore an RPI, because it's a hop header and it's a host, so it has to ignore that. Next.
Okay.
That's it then. Any question? I know that was quick, but I just wanted you to have the slides as a reference if you always wonder about what is written in use of REPL info and how that translates. I hope that these illustrations help you.
Yeah, thank you very much.
They do indeed. Yeah, thank you so much. I've read the draft, and having this drawing is very good.
Hello, can you hear me?
Yes.
It would actually be very nice to have this slides in the role working group repository alongside the draft, So it provides a good place for reference.
You mean save that on GitHub, you mean, when you talk about...
Yeah, in the GitHub. Yeah, it's in the,
good idea.
in the
I
GitHub.
can place them on GitHub. I just have to remember.
Yeah, thank you.
Do that. Yeah. Thank you. Good idea.
Okay, so I can begin. I can start.
Yes, please. Thank you, Raul.
Okay, so Michael, did you want to ask a question?
No, I was going to say the same thing Raul did.
Okay, all right, great. So this is going to be a quick update about the DCO status. So the document, the draft has been waiting for a particular value, the RPL status value. We finally have it. Again, thanks to the unaware leaves draft, we, I think, are in a final position to conclude this draft. Can you next slide, please? So this is the final value that we arrived at, 195. The reason being, this value eventually is the same value which 6low as well as RPL will be making use of. So it's like makes an implementation slightly easier, such that even if a RPL unaware leave or RPL aware node moves from one parent to another, the mood status would be same for both the cases. So it actually simplifies not only the implementation, but I'm hoping that in the future this would aid debugging as well. Yeah, so this is the only update that the draft has. Next slide, please. Next slide, please.
Okay.
The slide before. The slide before.
Yes, that one. This one.
Okay, so yeah, this one. So why 195? That is the slide that I'm looking for with the title why 195.
Just send these ones.
Next one, yeah. After
this one.
There is a slide in between. Yeah, this one.
This one. One. Yeah.
Latency.
Why
latency.
There is latency. Yeah.
That's a lie. Okay, so this gives us the rationale about what is this value. So if you see this value is a combination of values. We have RFC 8505, which says that status of mood. What happens? What is the status that should be given when the node, the 6LR node moves from one parent to another, which is the same value which RPL will also be making use of for RPL parent to RPL node movement across parents. The E and A bit has been newly defined, and this definition has been provided by unaware leaves. So that is what the slides talks about. That's pretty much it. The whole point about waiting for this value was to make sure that this we are in synchronization. We are synchronous with unaware leaves as well as 8505 changes. That's about it from me for this. I hope I can make use of my time for the next presentation.
Thank you very much, Raul. Questions?
Thank you.
Thank you. Okay, now Pascal, if you don't have questions. Okay, Pascal? Hello?
Yes, I'm coming. Okay. I was just adding the slides to the repo, so to make sure I did not forget. So I did that when I was listening to Raul. So yes, I wanted to just tell you about this cluster 310 because maybe some people are not too used to the way the RFC editor operates. And so, as you know, there are normative dependencies. Some drafts have a normative dependency on an RFC or on a different draft. And this creates a graph. And the RFC editor tends to group the drafts based on those graphs into clusters. So basically, interdependent drafts are grouped into a cluster. And there is usually like one draft or two drafts which kind of are not yet published, and they are blocking every other draft that has a normative dependency on them. And the cluster is kind of locked until the dependent draft are finished. The documents we're working on at Roll and at 6LO and at 6TiSCH, they kind of have this sort of interdependency, and the cluster that holds them is 310, cluster 310. So I gave you the link here, RFC editor cluster 310. Can you please move on? Okay, so there are in the cluster there are RFCs which are already published, and those three appear in 310 as published. So some progress can be done inside the cluster, some drafts can be published, and some others can be waiting. But there are other cases. Next slide, please. And what we are really interested in is, I just give one example of a draft inside this cluster, and it's the efficient NP-DAO. And we see that the efficient NP-DAO is not published as an RFC. And why? Because it's ready. Well, because it has this misref that you see on the right, missing normative reference. That's what it means. And the 1J means that it's just one hop, meaning that the graph is not deep. It's just that we are waiting for draft IETF raw unaware leaf to be published and as an RFC, and then immediately, and usually with almost consecutive numbers, the raw and efficient NP-DAO would be published. Now you see that the draft unaware leaf is marked as not received, and that's because the RFC editor only sees the RFC once it has passed the the IETF last score at the ISG reviews. So we just are making the publication request now, and that's why the RFC editor marks it as not received. Next. There are also other cases, like if you look at the use of REPL info. So I made the slides like two weeks ago, but I guess this thing has not changed. The marking is ISG, and that really means that the draft has been is now held by the ISG, in this case because we took it off the queue to do some edition, align with an aware, etc., and put it back. So it's marked as ISG. Other drafts like the APND are marked as ISG because the authors had to make some edition, and so the ISG has to confirm that these editions are correct before giving back to the RFC editor. So on the cluster pages from the RFC editor, you'll find the explanation for all those terms like misref or ISG. But that's basically what it means. Next. Okay, and you see that some drafts may have a high number of dependencies, and you even see an R2G there because the architecture needs an unspeaken, and then unspeaken, I don't remember which one. So that's 2 degrees now of depth in the graph. But when you look at all of them, most of them are in the RFC editor queue. The only ones which were not there are an aware leaf and MSF. And we were, well, MSF was ahead of an aware leaf, so is ahead of an aware leaf. It's mostly past the ISG reviews now. And so that's why an aware leaf was really the draft on which we had to pay particular attention, because you see it's holding many, many drafts. Go ahead, please. So in this cluster, actually, there are only 3 drafts which were marked as not received when I made these slides. So I gave the status. At the time I made the slides, there was only 1 yes missing and 1 discussed to solve. I've not seen that it's solved for MSF, but it's pretty much there. And the core stateless was on the ISG telechat agenda for 4 days ago. I have not seen the result, but I'm really hopeful that core stateless is now done. We just have to check the result of the telechat when it's published. So you see that unaware leaf is really the cornerstone that was holding 310. Next. I think we are. Okay, so
just on time.
Okay, so that gives you the latest documents that we've been working on and discussing.
Okay.
Great.
Thank you very much.
So how is core stateless draft dependent upon unaware leaf? So in your previous slide, I'm just curious to understand this.
The 60-ish architecture and the 60-ish minimal security drafts. Basically, minimal security needs core, and architecture means needs minimal security. So there is this relationship.
Okay, thank you.
Okay, thank you very much, Pascal. Further questions? Okay, thank you very much. Raul, please go ahead.
So I'm going to talk about capabilities and MOPEX. So finally, we had separated these 2 topics into 2 different drafts. Capabilities draft had a major update. We have major new sections. One of them, a primary section, was the recommendations for adding new capabilities. So what should anyone who is trying to add a new capability, what should they take care of? There are several bits, how each of those bits have to be handled. That is what has been explained in that section. New capability instances have been added. So this draft not only gives us the syntax about the capabilities, but adds specific instances now, which could be used for 6LoRH. Having said that, the capability instances are not specifically for 6LoRH. It is specific to 6LoRH, but for projected DAO, it can be made use of for any other any other purpose as well, and I'll get to that in subsequent slides. Security consideration, I think it still needs more work. We have added Ravi as co-author for most capability instances. 6law RH and projected DAO are added by him, and I think that is really a good work. We have fixed some of the references. Can we go to the next slide? So the MOPEX, there is no new addition here. There is no changes. Having said that, there is one point that I would like to discuss with the working group, which came up later which came up in a discussion last week. Anyways, that problem statement has been added to the observations draft, and we are wondering whether that problem statement can be taken care of in the MOPEX draft. But we'll come to that point later. This is a minimal document with a very clear motivation and proposition. We hope to take it very fast to the next level. There has been no design changes or any major updates to this document. Next slide, please. So this is one of the thing that was realized that we realized that anytime we are adding a new option, we have this backward compatibility issues. So this is not only true for enrollment priority, aligning DAOs and its extension. So what happens is a node which supports the new option sends an option. The downstream peers or the upstream peers who doesn't understand that option are going to strip that option. So what happens? So ideally, there should be some way of telling the upstream or downstream node, if you don't support it, at least copy it forward. So we are hoping that we can handle this in the MOPEX, essentially telling that whenever you define a new option, if the most significant bit of that option type is set, it would mean that the intermediate node has to copy forward. Of course, this means that all the nodes have to be at least supporting this draft, but once this draft is supported by the nodes, then it would result much lesser issues with backward compatibility problems, is what we're thinking. Does it make sense? It's not going to incur any new overhead. It's just about changing the interpretation of the option type value based on the most significant bit.
Raul, I completely agree. That was the sort of reason why we wanted at some point to say, okay, we are talking about triple V2, because we will place actually requirements on any Ripple V2 node, and being able to understand this particular specification is certainly a cornerstone of what it means to be a Ripple V2 node. So we'll know that those options will be processed as expected. So yes, it's completely important. The other thing that we usually signal is what you do if you see an option that you don't understand. Do you ignore the full packet or do you ignore the option? For instance, if I get a DIO with a certain option, and this is critical to joining that bag, not understanding the option, you should not process the DIO. So the only way to signal that is to have another bit. Exactly like 4 bits here, but which says ignore the DIO or process the DIO ignoring the option.
Okay, yeah, I got the point. So this particular point we have taken care of individually for capability options, but what you're saying is this should be generalized. It is applicable for any new option or any, yeah, that okay. But one thing is we don't have any option flags as such specifically for every option. So all we have is option type and the length and the option data. So the only place where we can make change, we can depend upon this these kind of bits in case of options is the type value. So it would reduce the entropy. It might not necessarily reduce because yeah. Okay, but I got this point. Okay, let's take this up on the mailing list as well. Thank you, Pascal. Next slide, please. So capabilities of update. One of the primary update that we wanted to do before was compare it with existing MOP. configuration option, and routing metrics and constraint. I can see that a lot of people are getting confused between how is it different from these three things. So there is an explicit section added on what you should do, what you should consider for defining a new thing as a capability rather than anything else which is mentioned here. There are some guidelines that have been defined for new capabilities, how to set the global flag, info flag, join as leaf flags. How should the node handle the capability if it does not support it before or after joining the instance? What happens if the node joins the instance and later it finds out a capability which says that I'm mandatory to support and it has already joined the instance? So things like this, the corner cases have been handled. And again, when to use and when not to use capabilities, of course, there is a different separate section on that. Next slide, please. Global and local capabilities. So this is one thing that was discussed on the mailing list before. We need to have a bit which says that the root has set this capability and no one should change it. This way, the root will be able to say that I'm supporting so and so capability without any of the intermediate node touching it. So there is a flag for that now. It's a separate flag. If you can see that the G flag is there. Yeah, that's pretty much it. All the intermediate 6LRs are supposed to copy the scabs in their DIOs as well as the other messages as well. Next slide, please. So there are two new capabilities, two types of capabilities basically that are added. So there are two types of capabilities. One are a node says that I support a certain feature, and the other type of capability is that I support a feature with so and so parameters or so and so capability. So there is an additional information. So for any capability which supports an additional information, we already have a definition for that, wherein a capability can have additional capability information. But for all the capabilities who are just a support or does not support a flag like indicator, we are trying to put all those together in a single option, in a single type. What it allows us to do is it allows us to reduce the control overhead, because if you keep having a separate option capability type for each of these indicators, then it would unnecessarily increase the control overhead for these messages carrying these capabilities. So we're calling this capability indicators group. Again, the name, I've taken this name from the Wi-Fi capability specification. They also call it the same thing. I think using anything else like capability flags would have, there is a big scope for misinterpretation there. So capability indicators group is the term that we're trying to use here.
Question, Harm?
Yes, Tom.
I see you've chosen to have 24 bits, but you still have the length indicator, which is free in this case.
Right.
Do you expect to be able to expand that in the future?
Yes.
And then how would the 24 bits map onto 32 or 48?
Yeah, so the idea is, in fact, till the time we are hoping that initially we can set this length to 1 as well. So the value, the bit, so what we'll say is that the second most bit of this value would represent, so we are hoping that we should be able to reuse 1, 2, 3 or any value in the future. Right now the draft mandates it to, I mean right now the draft says that it is length equal to 3, but for example the example T, the 6LRH flag which is specified here, T, it shows that the rightmost bit is set. I don't know how to put it, how can I phrase it properly. What I want to set is the location of the bit in that area dictates where it is, and we can change the length to any value, not only 3 in the future.
Okay, good. Thank you.
Should we be numbering these bits from left to right? So the T bit should really go on the left so that we can add bytes the right-hand side? Or did you intend the T bit to always float to the right in this case, the 0th bit?
I actually intended it to the right, but I think maybe keeping it on the left. might also be okay. So what I was saying is that 0x01 will be the t bit. If you set length equal to 1 and 0x01 is the only value, then it means that the t bit is set, which is the rightmost bit. We can as well make use of the leftmost bit, and that should be all right as well. I guess maybe that might be more easier to read, as well as
either way, we have some careful IANA text to explain where the open bits are. But people's brain might be simpler if we simply call these bytes, and we say the first byte of the capability, the second byte of the capabilities flag, and we make it clear that we can add bytes to the, I guess, end with more bits.
Yeah, that also sounds. So, is there any other draft or RFC which has similar thing, and I can just refer what they've done?
I don't know, but we could ask IANA.
Okay, all right, thank you. Next, please. Okay, so this is another capability that has been added. So this is a different capability. The node should be able to set how much of routing resource capability it has. What is the total capacity it has? Again, the capability length here is flexible. So if at some point of time, if it goes beyond 256, they can simply use a capability length of 2 and have 65536 as the maximum value for routing resource capability. This capability would specifically be useful for projection DAO, is what we are thinking. We are wondering if we should do something similar for neighbor cache as well. And if we want to do it for neighbor cache as well, shall we keep it in the same capability or have a separate one? I think routing resource is more required by PDAO, but maybe the neighbor cache might also have an implication on the route segment selection for projected DAO. So that would be a question. We can take this on mailing list if wanted. Next, please.
Oh,
yeah, that's all.
That was all. Thank you very much, Raul. And there are further questions for Raul? Okay, thank you for the questions. And Aris?
Hello, everyone. Yeah, sure. So next slide. I'm going to talk about the updates in the NSA extension draft. It's been some time. In the meantime, about 4 versions have passed. We have addressed a lot of feedback from Dominique, Raul, Fabrice, Pascal, and Diego. Thank you all so very much. So as part of addressing this feedback, we did a lot of editorial work. We fixed typos, we rephrased some sentences, and we defined some parts that weren't clearly defined. And one of the things we also did was reorder the structure of the paper. So initially we were describing the objective function that is contained in this work, and afterwards we gave some variations on how the objective function worked. And now we reversed it, so we give more examples up front, and then we go into the details of the specification. Next slide, please. Okay, so the first of the changes is regarding the objective function described in this draft. So we describe an objective function based on the common ancestor in order to do multipath replication and elimination. And initially we had defined 3 objective functions for 3 different variations of this, let's say, main idea. And we changed it. Now there's just one objective function. It uses the same OCP, and it just supports multiple policies, and I will explain that in a bit more detail. We also explained how these policies, the 3 policies that we describe, how they are ordered in terms of how restrictive they are. So we start from the most restrictive one going to the most relaxed one. And we also explain that there's a trade-off in terms of energy consumption and reliability. The strictest one consumes less energy but provides lower reliability, and the more relaxed one consumes more energy but is less reliable. One of the changes we also did is regarding this change from multiple objective functions to just one. So these objective functions are local to each node. So the only information the node, the decision is made at the node based on information received from other nodes, but the decision at the end of the day only regards this node. So it decides where to replicate the packet. So there's no need for multiple objective functions. Each node can make the decision in their own way. Multiple nodes can use different policies if they want to. Of course, an administrator can make a change and force them all to use the same thing, but there is no reason to restrict this in the draft itself. Next slide, please. We also provided more details about the information that is required for this objective function to work. So we extend the DIO control message, and we put some extra information in the DAG metric container in the part of the node state attributes object. So we define a new TLV, which is inserted there. And before it was a bit low on details, we have now specified exactly how the addresses that are carried inside are represented, how they're stored in the field, how you can derive how many addresses are present, and what their order signifies. So in this case, it signifies decreasing order of preference. Finally, we say that the implementer can choose how many addresses they will store depending on the requirements and the restrictions that they have in their network. Next slide, please. One relatively late change after a discussion with Dominic, thank you for that, by the way, was that we identified that we initially described this information in the NSA object as a constraint. We use this information in order to restrict which nodes can be used for replication. However, Dominic pointed out that if you have a constraint in a DIO packet, you also need to have a corresponding metric. So because it does make sense to also have a metric, we changed the definition from a constraint to a metric. And we also set the flags for this metric to be carried in recorded mode and with the partial flag enabled, because this is information sent from a parent to its children. It doesn't go further away. So it's always partial information. You don't get the information all the way from the root of the DODAG. Finally, we also we try to clarify that this metric is not actually used to modify the rank of a parent, of what rank a node would get through a specific parent. So it's only used to filter out potential parents, nothing else. So it basically operates in a way as a constraint, but it's carried as a metric. Next slide, please. We also described finally some considerations regarding the security aspects of this draft. So basically the main addition is that we carry inside the DIO the addresses of a node's neighbors. So a node can potentially have a small privacy issue, a small network discovery issue. So a malicious node can see one hop beyond its immediate neighborhood, which it is an issue, but for me it's not like a super bad issue, but we did highlight this in the draft. And secondly, a potential problem with rerouting. So a malicious DIO sender can modify what the parent set it reports, and that way it can trick other nodes into routing through itself and taking over the routing. However, this is already possible by just reporting a fake rank, so this is not really a problem. At least it's no more problem than it already is in these terms. Next slide. And this is basically it. We have tried to address every issue that was raised. Some issues required discussion. We did it in the mailing list. As far as we are concerned, there's no outstanding issue anymore, and we'd like to find out where we can go from here. Thank you very much.
Thank you very much. Some questions?
Yeah, I have one point. At last meeting, we discussed whether we wanted to compress those addresses, yes, because we know, this is going to carry IPv6 addresses. So I think both myself and Pascal, we said, let's ship this draft first and then see how we do the compression. We just need to make sure that we have a way forward, that we have a path by which we know we are going to be able to compress addresses. So I just wanted to make sure if we need any flag, any hook, anything that says this is the uncompressed form and the compressed form will be slightly different. To just make sure we have a vision for the way forward with compression. Any suggestions?
Yeah, so actually, I don't know if you remember, but initially we did implement compression right in our draft. So right, we took the example provided by 6LoRa, the source routing header, if I remember correctly. That's the name of the thing. Michael proposed that, and we implemented that for the set of parent addresses, and that worked. We actually have code of that. But after discussion with Pascal, he said that an idea would be to have a separate draft that just handles compression for all control packets. So a more general approach instead of doing like a special solution for every field, and that might be much more efficient as well. So we took that out. I think that as far as we are concerned, the 6LoRa use of compression worked reasonably well. So we can use that in a compression draft as a technique, but we took it out because of these concerns.
Right. So I still stand by this decision that we have a homogeneous way of compressing IPv6 addresses within Ripple control messages. So that's clear. But my question is, do we need anything in the format of this metric or anything, any signal that needs to be in this draft so that we can tell apart which ones are compressed, which ones are not compressed?
So I would assume that the fact that you can deduce both which are the addresses in the field and how many there are just from the size is enough. This is a very homogeneous format, right? You have your type, your length, and just a multiple of 16 bytes, one for each IPv6 address. Now, when you do 6LoRa compression, typically you use the same compression level for each IP address in a set of IP addresses. So if you, let's say, compress each 16-byte address to 8 bytes, then all of them in a set will have the same compression level. If you want different compression levels, because say one is the root, for example, and the others are not, so the root can be compressed further than the others, then you need to create two sets of, let's say, compression sets. But I don't see why this would affect the uncompressed format in any way. You still maintain the same order, so I guess this is completely up to the compressor to solve.
Okay.
I don't know if we should provide something else. I would assume that this extension would be agnostic to compression in that sense.
Right. So we said we could use capabilities to tell which nodes are able to understand the compressed form. Then the question is to be able to tell which messages use the compressed form, which do not. So you're saying based on size, that would be the way to tell?
No. So, okay, that's the thing. If you want to be able to compress, so my thinking for this was that you either do compression or you don't. And if you do compression, then the compressor does need to figure out a format of signifying which parts of the control packet it has compressed or not. And that would go directly into the work of the compressor. It wouldn't have anything to do with the uncompressed format. If you would like to do a piecemeal part, so some parts of the control packet are compressed, some others are not compressed, and a node that supports compression needs to figure out at runtime which parts are which, then maybe we should add a field maybe indicating compressed or not, something like that. But I don't know about it.
Well, any opinion on this?
I have an opinion about the compression part. So I thought what we discussed previously was that we should have a generalized compression which would work across not only this set of addresses but other set of addresses as well. For example, multiple targets in the DAO message. I don't know whether the same should be used or whether it cannot be used. Regardless, it would be really these addresses are sent as part of DIO message, and the DIO message is a multicast message. We know that we cannot afford to bloat it any further. So it would be really nice to have, in my opinion, again, I know we have already discussed this on the mailing list, and we have already decided not to do compression, but it is my personal opinion that compression is a must for this, because without it, it might not be feasible, in my opinion, to So even if you have two addresses, it is like 32 bytes, and it's too much for DI message. Is what I'm trying to say. It will bring down the whole utility of this proposal.
I agree. In our implementation, we use the compression, right? So
exactly. That's why. Yeah, I remember.
I think we all agree we eventually want compression. My question is, if we ship this way, then are we not shooting ourselves in the foot and making it impossible to have compression later on? So if anybody has a clear vision on how this is going to work.
I did some work on this in the early days of the before 6550 was shipped. There was an appeal to rip out all the options, in fact, to rip out all the TLV processing and basically have a static header that would contain all the important information which we'd never extend, right? And I thought that was dumb. And so I wrote about 20 lines of C code that implemented generalized header compression. This is Carson's document that never really progressed, or maybe it did finally. And that I showed that basically with this fairly stupid compressor, like 20 lines long, I was able to take an 80 byte DIO message and make it about 37 bytes. And the proposal was for like 32 bytes or something like that was the header. And I thought that kind of nailed the application specific compression in the foot. But we never went ahead with any kind of generalized header compression. That's what I really think we should do, because that would compress any IPv6 address in any option wherever we put it fairly easy. Well, this didn't use a dictionary. This was stateless, but we could do better. I mean, there's ways of doing better, and GHC lets us do better incrementally. Like we can build. It's up to the compressor to decide how smart he's going to be. So that's what I would suggest we do. And that we would essentially create a ripple level header which says the rest of this stuff is compressed, and that itself would have to be negotiated as a capability. We would know if all the nodes support it, then we can use it in multicast messages, and if it's only some children that support it, then we can only use it in unicast messages.
Agree. I think this also gives rise to opportunities for further compression. For example, maybe you have a target option as well. What if you have the same IPv6 address in our extension and the target, for example? Then you can eliminate it from both places if you have like a global compressor. If you just have specific compressors for each small part, then you can't take advantage of things like this. So, yeah.
There are two angles. I know I'm the one who talked to you, Remus, about we need a generic because I really remember Michael explaining us the benefits of GHC, etc. There are two other angles that we need to keep in mind. So GHC may not be enabled on every node, and that would what preclude those nodes from participating to REPL. So if we really think GHC's direction, maybe it should be one of those things that must be present in every node in V2. So that's REPL V2. So that's one thing to keep in mind. About the compression itself, if you look at DAO projection, I'm not using the full addresses. We had that discussion long time ago as well. And since in the meantime, we made 8138, so we have a compression for REPL data packet for the source routing header, for instance. So for DAO projection in particular, when it uses source routing, it made sense to use the exact same compression. It's a very simple compression, right? Mostly lines to zeros. And so basically says what is the significant part and what is inherited from a reference. So if you have a reference which has like 14 bytes, which are always the same, then you just have to write 2 bytes per address in the compressed form.
Exactly, that's what we implemented.
Yes, so that should be the reference, the default model everywhere until we have GHC or something on top. But I think that's the standard way for REPL for now. The other thing being that with the draft I'm going to discuss later, we don't have to place every option every time. So we'll be able to just say, oh, that's the option like I presented so many DIOs ago. And so by having not to reproduce every option every time, we also have some kind of compression. What's important is you don't necessarily have to place all the options in all the DIOs. So if you don't have enough room in one DIO, you may have to send 2 DIOs in a row, and that has to be very, very well considered when you have options that are mandatory or something. Because imagine that a guy gets one DIO and not the other. The mandatory options are in the DIO that gets lost. So that's something to consider in the capability and the MOPEX draft, actually. So we have to remember this sort of thing. So all this must work together correctly. But yes, the default for now is to do as you said, and as we do also in our projection, right? The simple one, which does not require any support like GHC. And I'm really open to discussing whether GHC become a standard feature of REPL. Then again, you would need an RFC. Right?
Okay, sounds good. So we have many options that need address compression, so we'll have a wide look at that and use a generic approach, but not craft any individual stuff. And what I hear is that
is the standard way we do it now, which is 8138, which is very, very simple. You just put significant bytes and all the common bytes are elided.
Right. And okay. And so we're saying that we don't need an extra bit of flag specifically in the NSA extension because we are going to have a generic mechanism that works above that level.
I think so.
Okay. Sounds good.
So next step.
So I guess regarding your question, working group last call, yes, I think we're going to issue that on the mailing list.
Okay, great.
I haven't heard any objections, so sounds good.
Thank you very much.
Thank you.
Thank you. Great. Thank you very much. Raul, want to give us a yeah. Can you see the slides? Yeah.
It's RPL observations again. So we have an update. Next please. So we had the discussion about adding a section about trickle time of recent and its handling, and it's there now. Again, the backward compatibility issue that I mentioned before is mentioned as a problem statement in this draft. the same problem that I mentioned. If we add a new option, how do we ensure the backward compatibility? It's the same thing that is mentioned here. Next slide, please. So one of the major, so we have kept discussing about DAOAC so many times before, and we finally decided to do something about it. We have a new draft which takes, which sort of tries to handle the problem statements towards this this section. So just to briefly tell what the working group it is about, I know we have already discussed this a lot of times before. DAOAC is a local signaling in case of storing mode of operation target. The primary problem statement is that the tiger is not aware of the end-to-end path establishment. So whether to start an application, traffic, it's that the target needs to know when should it do it. If not knowing it, in case of multiple hops, if the node is 5 hops deep, then it really has major implications on the overall packet delivery rate and the control over it that is induced. Another problem, I think we don't need to go here, but if an intermediate 6LR for some reason induces a negative DAO status, how should it be handled? One of the point was that the node, that the child node who has generated the DAO packet has to in turn take care of the handling, but there are some issues with it, and the observations draft has clarified it. This was discussed again in the previous session, so I won't go into the details there. I would like to present the solution. Next slide, please. So, okay, forget the right-hand side graph for a moment. Just concentrate on the left-hand side graph. So, what we are suggesting is the root node sends back a DAOAC directly to the node, the target node, with the TI option, which has the path sequence. So, in this way, basically the root node can inform the target node whether the end-to-end path has been established. There are several issues with this, and I'll come to those points in the subsequent slides. So this is the fundamental proposition that in place of so we are not deprecating the existing DAO-ACK mechanism at all. It is possible that the existing hop-by-hop DAO mechanism is implemented at the same time this mechanism is also implemented. The only difference between a hop-by-hop DAO-ACK and this DAO-ACK is that the root node will send back the transit information option to the target node. Why transit information option has to be sent back to the target node? It's because the target node needs to know for which DAO is this DAO-ACK sent for. And every target is attributed by a path sequence which is present in the transmit information option. So this graph basically shows the different attributes which have to be passed. So one of the things that this mechanism also enables is that the border router can actually tell the target node as to what kind of route lifetime it should use. For example, the target node decided to use a route lifetime of 3600 seconds. Finally, the DAO reached the border router. The root might say that, okay, you can't use 3600 lifetime. You have to use 1800 seconds. Now this is possible. This was not possible before. So there are some side effects, positive side effects to doing such a kind of thing.
Can I? Do you mind taking a question now, or do you prefer take them at the end?
Yes, yeah, it's better to take it while we are on that slide. So let's go back to that slide.
Okay. Raoul, so I really love the idea. I mean, we discussed it many times. Yes, it does not supersede the DAO-ACK, so the call of the DAO-ACK is a bit different. Maybe it does not even need to be called the DAO-ACK. It's more.
Okay.
You present this really in the case of the first DAO, and you present it like N21 sends a DAO, N11 will send a DAO immediately, like this DAO. But the original intent was more like And 11 could aggregate mostly in runtime, not on the first one, but in runtime. And 11 would periodically send a big message with many DAOs in it, many targets in it, in a single message to just give its current status and do that on its own period. The first DAO is a bit different, but the other ones are not like that. So I believe that what you really care is the first DAO. So that's really when the root finds that it has reachability to a new node. And so this is not really the DAO hack for the periodic DAO. The periodic DAO could be set by every node on the way, aggregated on their own time. And since the path is already enabled, the refresh doesn't have to be very precisely when the N21 sends the DAO. So this DAO hack could wait a long time. It does not matter when you just refresh, as long as everything is done within lifetime. So
absolutely. So
yeah.
Sorry. You go ahead. Please continue. Please finish here.
The way I see it is, it's more like a very specific mechanism for when we instantiate a new route, and N21 wants to know that it's reachable, but it does not really apply to the refresh of the DAO, just the first one. Whereas the DAO applies to every refresh.
So
yeah, go ahead.
Yeah, so Pascal, that's a very important point that you mentioned. So essentially, the first DAO needs to be taken care of with this DAO act, with the signaling. Even to call it a DAO act, we also thought about it. I was thinking about it whether I should be calling it a DAO act because it's basically an asynchronous message which gets sent to the target. So that is
you're reachable.
Yeah, you're reachable. So we should not even be calling it DAO-ACK. But for the sake of this discussion, let's call it DAO-ACK. I'm open to changing this term, this name. I think we should change it. Essentially, what it will allow us to do is this asynchronous message can take care of certain other problems as well in the future, because this is the first time in storing MOP we have a message from the root directly sent to the target node. Your second question, the refresh DAO. So basically, that is what I was coming to. So the only change that is required in the transit information option is that the setting of this K flag, which says that acknowledgement is sought, or some sort of response is sought, your reachable response is sought. Now, when an intermediate 6LR sends a DAO, a refresh DAO, it won't set this K flag, or it should not set this K flag. It does not make sense for it to set this K flag. So the refresh DAOs won't result in the same message getting sent back to the target node. Only the initial message will result in this message.
I have one more question. Like, apart from the refresh, we have also parent switch case, right?
Yes, but parent switch, we don't need to inform the target node that you are reachable because it is already reachable, right? Yeah.
But if he switched because of some it is not able to reach to the previous parent and it is did the switch, then in that case also it needs the reachability information, right?
So if the target node thinks that it needs to know, then it can set the K flag. So what I'm trying to say is that the target node is in charge of setting this flag and letting itself know whether the complete end-to-end route has been set or not. So if in this example, if N21 decided to switch to N22, it can set the K flag again or not set the K flag again. I mean, it's completely its call, but ideally I would set the K flag because I want to know whether the end-to-end path is there. But if N11 switches on behalf of N21 and sends N21 as the target, then it need not set the K flag for that part. Yeah. I mean,
and should the DAOs?
I'm a bit concerned in piggybacking this information in DAO because the DAO is maybe, as you said, the first DAO is just copied as received all the way up. But normally the DAOs can be completely regenerated by the intermediate nodes.
Yes.
They don't
Yes.
have to be stored and forwarded, meaning that should we store this K flag, and then should we put it on every copy we send up until we get a DAO from below, which doesn't have, we can at some point, there are cases where by changing I don't remember the acronym, but this flag in the DIO, the parent can ask the child to give all the list of all the DAOs that it has. So basically empty its routing table and give all the routes that it has, just to resync the parent. So should the K flag be used in those cases? Is it something that the intermediate nodes need to learn and remember when they reproduce the DAO?
So the K flag is very similar to the E flag in that aspect. So an intermediate node has to also remember that the E flag is set on behalf of the target node. So it's the same. Yeah, it is one more flag, but it has the same aspect or same characteristics as E flag. It has to.
E is a proper. The E says that it's an external route, right? And
Yeah.
that's a physical thing. It's not something that changes over time. So it can really be stored by the intermediate node like N11. And if the backbone router polls N11 and says, give me all the DAOs you have, N11 can, based on its tables, rebuild the DAO with E, and the E will be valid. But should it store K? And should it, if it stores Ks and asynchronously BR asks N11, give me all your DAOs, and N11 sends the list of DAOs, if the K is set, then all of a sudden the root will send a DAO ACK to the N21, and N21 never asked that. So it's not, it's a request. It's not a physical property of N21. E is a physical property of N21 that doesn't change. Here it's more signaling. And so I'm concerned a little bit. I know that somehow it cannot arrive to the root before the DAO arrives to the root, because how would the root send the packet back? On the other hand, it's hard to signal it in the DAO unless we say, hey, if you forward the DAO immediately, then you leave the K bit. But if you store it in your database, in your logical database, RIP, then you don't store the K flag or something. It's not something that you can reproduce asynchronously. So it's kind of weird for me to use that. And it's not like there is an easy answer of what's the best way. Well, I was thinking about exactly that when I asked you that point earlier. And my conclusion was, there should be a setting in the root, basically, that says, if this setting is there, each time you get a new route, like N21 shows up, then you send a packet to N21. But the problem is, if N21 moves,
it moves.
the root might not see anything new, and maybe N21 wants that information. So it's kind of, basically the way I see it is, there could be a toggle, a setting in the root which says on the first appearance of N21, you send asynchronously this message says, okay, I know you're here. And asynchronously, when N21 moves, it may ask, am I reachable? Unicast to the root, and the root will answer unicast, yes, you're reachable. It means first time proactive and then on demand. Now,
So on demand, yeah.
The last thing I wanted to say
is a kind of a ripple ping.
It's a ripple ping. Yeah.
Yeah, maybe that's what we actually really should be is that, rather than try to do this here like this. I think for the reasons that you said, Pascal.
The problem with the ripple ping is the first ping, right? What triggers the first ping? Because you can't, if N21 sends a DAO and the ping, it might be that the ping goes faster than the DAO. Another root receives the first ping, but does not have a route. So what does it do? So that's why, I guess it was piggybacked inside the DAO, kind of to say, hey.
I like the idea that the root sends an acknowledgement to every time it gets new reachability information.
So that's the asynchronous ping then.
Yeah, that's the oh, you're new. Welcome to the welcome to the thing. And actually, that's kind of an opportunity, actually, even to do capabilities exchange. What are you able to do? Then afterwards, then maybe there's something in there in that thing that enables dates later on where the root says, "Oh, and who's your parent today?" And it's not it's a survey. It's not an exhaustive survey. It's just a regular survey. And we talked about this in capabilities that you might have to do that regular survey. I think at one point.
Yeah. So where we are is you are establishing a connection kind of between N21 and the root. The first time N21 shows up, the root tells, hey, based on the configuration that it has, it should basically tell N21, hey, I know you're here. And now when N21 moves, it can ping the root and check that the movement was actually done.
Okay, Raul, you have 1 minute more. Sorry, guys, we should move on.
Okay, but still we have a problem that the initial okay, initial DAO. So okay, so this
in the mailing list, and you present the
let's go.
document because yes, please. Thank you.
Okay, next slide, please. I mean, I'll move faster. So there are a lot of points to be considered. Target aggregation and DAO. So there are a lot of points, frankly speaking. All these are considered already. I hope we can get some reviews. And one of the primary point that Pascal mentioned, I'll take it. Pascal and Michael mentioned. Michael also has mentioned that point about using ping and pong like mechanism. So one thing, we change the name of the message from DAO to something else. Okay, next. Right. So I wanted to discuss about other things as well, but it looks like we don't have time. I wanted to understand how do we handle the observation chart, because still there is some other work that. Will all the other points also? Since we are not going to take it for, we are not going to publish Ripple observation. There are some other aspects also. Lot of aspects does not require the whole new draft, but it is still not an errata. So how to handle those things?
Yeah, we plan probably to have another meeting at the end of May so we can raise all these issues, topics. Thank you very much, Raul. Georgios? Hello? Are you there? Thank you. Please move on.
So this is the use cases for DNS notification draft. Next slide, please. The objective here is to identify and group the use cases that prompt DIS modification. So we already have several drafts that discuss and request modifying the DIS control budget. So I have here the Ripple observation, eliding DI information, and the DIS modification. Next slide, please. Next slide, please.
Is slide number 3, use case node joining DODAC, that one?
Oh, yes, yes, thank you.
Yes, is there. Can you see it?
Yes,
okay.
I had a delay. Thank you.
Okay, yes.
So this first use case is about a node to join a DODAC. So typically we have a smart meter that being replaced or a new meter that is placed in the field while we have a Ripple network that is running already and it is in a stable mode. According to the RFC 6550, the meter will wait for the DIO, which it might take long time if the trickle timers are in relaxed mode because of the steady state of the network. Alternatively, if the meter will send the DIS packet, it will send in multicast because it has no information about the Ripple network that is running. So in that case, we will have the nodes that will receive this DIS in multicast to reset their trickle timers, and thus we will have a bunch of DIO packets back to back. And second thing is that this DIO responses will be in multicast, which then will trigger to consume more energy in these nodes. Next slide, please. So in DIS modification drafts, a potential solution could be to add few flags and options inside the DIS control packet. So for instance, with no inconsistency flag, the receiving nodes will not reset the trickle timers. With DIO type, these nodes will send back in unicast at DIO. With response spreading option, the nodes that receive the DIS will not respond at the same time, and thus we will avoid the collisions by sending at the same time the DIO packets. The DIS control packet, furthermore, may include meter container that will list routing constraints, and then the nodes that receive this DIS will respond only if they satisfy these constraints. So we have less nodes that will respond to the DIO. Next slide, please.
Done. Use case identifying defunct DODAC.
Thank you. So the next use case is the identifying defunct DODAC. I will skip this slide. Next slide, please.
Yes.
So here we have a node that will continue to consider itself attached to a DODAC, even if all its parents in the DODAC are unreachable or have moved to another DODAC. So in such DODAC can be characterized as being defunct from the node's perspective. And the problem is that if this node maintains the state about large number of defunct DODACs, it may consume large portion of its memory. So next slide, please. So to tackle with this problem, again, a DIS message can be sent with flag such as inconsistency, no inconsistency, in order to not reset the trickle timers from the other nodes. It may include the solicited information option with I and D flags in order to identify the DODAC, and a response spreading option in order to specify the suitable time interval over which the DIO responses may arrive. Next slide, please. Of delays.
Use case adjacencies probing.
I do not see this slide. Yeah, okay. So now. So the next slide comes from the draft of Raul of ripple observation, so the adjacencies probing. Now, in order to reduce the control traffic overhead, ripple comes with the trickle timer algorithm to update the configuration parameters. But the problem is that when we do not have actual traffic, regular traffic, or layer 2 traffic at, for instance, the enhanced beacons, the adjacencies cannot be tested and therefore cannot be repaired if they're broken. Now, 6550 comes with mechanism in form of unicast DIS to trigger a DIO from the other nodes. And the nodes that receive this unicast DIS will respond with the unicast DIO, including configuration options. Now, the discussion part of this use case is whether this mechanism could as well be made use for probing adjacencies. Next slide, please. So the question comes, and it's the following: should the probing scheme be standardized? And there are a few recommendations. That the frequency of probing dependent on the traffic conditions. In some cases, DIO probing the neighbors by setting the DIS in multicast can be advantageous. And probing can happen in both directions, meaning parent to child and child to parent. So these are things that we may discuss. Next slide, please. So hereafter, I will have a few slides to show you some preliminary results that we have by implementing DIS modification and to see the benefits. So we are working on this with Aris and our new intern, Dimitrios. So we work with Kuja and Kontikinji. We have a small network of 10 nodes in grid topology with a ripple and 60 minimal at the layer 2. Next slide, please. So here we have the default version of 6550, where there are no flags and no options. And as you can see, in the node 6 is the one that is willing to join the network that is already running. And the background of the node 6 in gray color, it means that it has no radio, so its radio is off. And in red color means that it has no parent. So, and when it turns on green color, it means that it got a parent. So around at 30 minutes, the node 6 turns on its radio and sends DIS multicast control packet. And according to 6550, what you see here, it will happen. Basically, it means that all neighborhood nodes will respond with DIO back-to-back in broadcast, and they will reset their trickle timer. And that's why you see this burst of DIOs one next to each other. Now, if you go to the next slide, by including, and I will go quickly here, by having, for instance, the N flag only option, the nodes that will receive this DIS, this multicast DIS control packet, they will not reset their trickle timer. So they will send only one. Here, as you can see, we have 2 or 3 sometimes DIOs back to back. This is because the problem comes from the 60s minimal. We do have collisions when they try to send back, and that's why they try to resend this DIO control packet. And if you go to the next slide, please. Thank you. We solve the problem by including N flag and response spreading between 0 and 2 seconds. And as you can see in the bottom figure, we avoid the problem of the collisions, and we do have only one DIO transmission in response from the nodes. So if you go to the next slide, please, I will skip the next one. Next one, please.
NT flags MC.
Next one, please, so that I will have more time.
NT flags MCRS.
So much. So this is the final with having the 2 flags and the 2 options. Basically, we have N flag for not resetting the trickle timer. We have the T flag in order the devices will transmit back in unicast. So this is the green color that you see in X. We do have the metric container that includes constraints. Basically, it says, for instance, if the rank of the node that receives this DIS is higher than the X and Y value, if it satisfies, then yes, you can send back your DIO. And RS option in order to give some spreading so that we do not receive these responses at the same time, so we do not have a collision. So as you can see in the bottom figure, we have only 4 green responses. So basically we reduce by half the nodes that will respond. They do respond in unicast because we have only the green colors. And they do not send at the same time, so we do avoid the collisions. Next slide, please.
Roll forward.
Thank you. And this is my last slide. Here I'd like to initiate the discussion. If you have more use cases that we are missing here, please let us know, so we will include them. The next question that I would like to discuss is whether you think this draft should be in the appendix of a solution draft or not. Third question that I would like to discuss or initiate is whether, as a working group, we are going for a single or multiple solutions. So far, we have a lighting DIO and DIS modification. Thank you so much.
Thank you very much, Georgios, for making it fast. Questions? I think it would be nice to have comments about these use cases, since are useful for this modification draft. Questions? No?
See how eliding DIO and this modifications are, I mean, eliding DIO and this work sort of overlaps with each other. I see there's no, I mean, there's hardly any overlap between these two. I mean, eliding DIO is a different proposition altogether.
Actually, well, this is Dominic speaking. Eliding DIO has a request for DNS modification as well.
Okay. All right. Okay. So that happened, right? Yeah. Okay.
So we do want to design a common solution, not fight.
Okay, thank you very much, Giorgio. Yeah, Dio,
So-
Elaine Dio, yeah.
Yeah, so please, again, if anybody in the working group has another reason why DIS should behave differently than it does in 6550, then please let us know, so we can design a solution that works for everybody. We really need that, and Dimitris is with us to run simulations, make sure we do it right. So now is the time.
Thank you very much.
Can I?
Yeah.
We had a number of discussions for this modification, and I'm a big supporter of this work. I think the use case is important, and one use case that really hurts us in the past in the field is the use case where you have a power down. We have smart grid applications of repos, so we have this area which is power down, like the power is cut, and then all of a sudden there is a power restore. And so all the matters, all these devices, they kind of power on at the very same time. And that's an interesting use case, because if we just do the DS in a fashion that the devices don't know that the other devices are suffering from the same thing, then they might actually be sending a lot of traffic, this traffic, which would possibly even prevent the reception of the IOs. And in that case, that's exactly the opposite you want. You want to do this, and you want DIOs. And all the space must be used by DIOs to form the new network. And everybody crying out, hey, I lost my parent, I'm here, I'm looking for a parent. It's a very bad idea. So it's a use case where you want to determine that you don't want to send this. So we have to be very careful of basically, last time we discussed that, Dominic, we concluded that it could be good to have a button, something on the meter, to trigger this like the ones you are describing here. Because the guy who installs the new meter, he knows that it's just an asynchronous device, not a bunch of devices that could be rebooted at the same time. So what we want is very different in those two use cases. Right. Not differentiate them from just one device booting.
Right. Very good point, Pascal. We'll make sure to capture that in the document. And yes, at hardware level, the device can tell the difference between power up and button press or something. So it behaves differently.
It's very hard on booting. The only thing you could do is do something like trickle. So when you boot, you refrain from sending the DS. You listen, and if you hear a lot of this, then you refrain from sending a DS. So you kind of trickle out the DS just like you trickle out the DIOs.
Right, but on provisioning, you're not booting.
If you're booting, so normally the behavior would be I boot, and I send this asking from unicast and saying this is not discrepancy or whatever, but
inconsistency.
Okay. I was okay, but in that, if you trickle them out, then you can actually listen that other people are doing the same thing, and then you don't.
Okay, we're running short of time, but we'll definitely take that into account. Thank you.
Just have it in mind when we design.
Yeah. Thank you.
Thank you. Michael, are you there? Thank you.
Good.
Please.
I'm here. Good. All right. So I when I made the slide, I realized the title of the document maybe is a little bit wordy, and welcome changes to that. Next slide, please. So we split this document off from 6-ish Enhanced Beacon in 2016, and it had the name join in the title, which was confusing because people thought it was about DODAG joining. And so as much consistently as possible, it now says enroll or enrollment rather than join. It says version 02, but I meant 03. And I've removed all the remaining references to the word join, except for join proxy, from the document. To be clear, this is not about joining or finding a parent. Next slide. did that. Added a section on what to do if the option is not present. Next slide. So I'll just run through these. Pascal, I used your diagram. So here's a bunch of a DODAG, 51, 52, 53, and 25 are nodes that are trying to join. They have a little duck on them. Next slide. So what we assume is that this new priority would come out, and I'm just going to say it comes out with a hexadecimal 10. Next slide. And it spreads, and each node at each layer, as it sees that in its DIO, adds some value to it depending on its local congestion when it announces. Next slide. So in this case, node 13 is sending an enhanced beacon. Well, probably all of them are sending beacons, but this one's the only one we care about. And let's say it contains, the enhanced beacon contains the value 22, which is what it would have broadcast had it been, or 23 would it broadcast had it been there. Next slide. So in the case of a deeper one, it continues down. Next slide. The color gets darker as the number gets higher. And what happens is at the end, you get a number, in this case 72. 51 sees this value 72. Next slide. And it goes to another track. Next slide. So in this case, 32 has discovered that he's full. He has no more neighbor entries or his storing node, and the routing table's full. The exact reasons are not important or specified, but the important thing is that he's full, so he sends us 127 7F value down to 42. Next slide. And so 42 still sends his enhanced beacon, but he sends it with a 7F, which tells 51 and 52 that this is really a bad place to join or enroll. Next slide. So it comes down 33, lower value. Next slide. Next slide. And 43 announces this much better value of 52. And so coincidentally, node 52 is going to enroll to his right to node 43 rather than to his left to node 42. Next slide. What did I change? Oh, it's an impaired node. Okay, so in this case, we're going to have an impaired node, which is node number 24. Okay, so that's the 2 layers down. So it receives the 23, but it doesn't know what to do with it, so it deletes it. Next slide. Does not support this option. Next slide. And so number 35, when it receives the DIO and it doesn't see this value, it assumes the value of 40 of 40. So that's a 64. So that's the halfway value between 0 and 128, 127. And this number is certainly open to discussion. Next slide. So it adds some value to this based on its own local condition, announces that. Next slide. 46 happens to announce another value, 51. And so that means there's still a value, still has something to say, but it may be inaccurate. There may be no real connection between 35 and the conditions at 24. 24 can be completely full. We don't know. Next slide. And obviously there's other announcements there of another value. Next slide. That's really it. As I said, I added this section on what to do if there's no value. And there's some discussion about what would happen if the option wasn't present. And if the option wasn't present, then we would still have the problem at 24 that it was congested and no one knew. But at least we have a little bit more management in the sub-DODAG of what's happening. And as I said, maybe there's some other better default value we can pick.
Thank you very much, Michael. Questions? No? We would like to have review of this document, please.
Pardon me?
We would like to have a review, like people read it, review, so we can move forward with the last call. Thank you. The last presentation, Pascal, you have 10 minutes.
Okay, so this is, for some of you, it's a new work. For some of you, it's more an older work. So this is a draft that we kind of decided collectively to do during one of the role interim meetings, what we saw is that there is more configuration information that is being exchanged within the Ripple protocol. And that's very important to us because we care about what we call autonomic properties, meaning that the device can boot with almost zero configuration, and they will learn from the protocol how to operate the protocol. It's like you don't have CLI in the IoT devices. All the quote-unquote CLI has to come from the root. But then the more and more information we place there, the biggest, as we just said earlier, the DIOs will become to the point that it's unbearable if you have to provide this information all the time. We already foresaw that with the Ripple configuration option. And so we said, hey, you don't have to place the Ripple configuration option in every DIO. But guess what? If you don't, then some nodes will boot and get DIOs, but they won't have the configuration. And they don't even know that they're missing it. Or it could happen that the DIO is sent with the configuration option with a change in it. And some node did not hear that DIO and still operates on the old configuration. And there is no way to know that this node is desynchronized, quote unquote, in terms of configuration versus the other nodes. So we discussed that and together at this interim, and we decided to have some form of synchronization information, like database synchronization, if you like, a bit like when you synchronize LSDBs in a early state, just to not synchronize the routes, but synchronize the configuration, make sure that every node has the latest information about configuration. And as we go, we realize that it's not just the Ripple configuration. There are actually 5 options that are concerned with this problem. So the idea is, let's put something in DIO so that nodes can know whether they have the latest or not. And if they don't have the latest, let's do something with the DIS. And that's what Dominique was telling us a few minutes ago. The DIS is actually used in this document to be able to pull a new version of the configuration or the other options that we cover. Can we go down? So I have not been working on this draft. I mean, we did not discuss it much on the mailing list either since IETF 106. And the reason is, you know, the Ripple Unaware and the turn on 8138 were already a lot of work. I mean, with the chairs, we work also, and Michael, we worked on the use of Ripple info. So all this was a lot of work just for this group. So we can't, you know, move every card at the same speed. So this one was kind of in back burner, but it's probably cool to look at it again quite soon now. It's also something that we have to probably integrate as part of this a bunch of RFCs that we want to see as core for Ripple v2. So I'm asking, is it a good time now to start working on this again? And the same question would apply to NPDAO probably. And so I don't think I've republished since the split of MOPEX and capabilities. I know I was on it to do some edits, but I don't remember if I republished. Next, please. So basically the goal is not to have to place every option, and we'll see that there's a slide on the list of options, in every possible DIOs. Also enable to place options in not just one DIOs, but a sequence of DIOs. And to be able to ensure that, then we need to do something so that all the DIOs, which represent the same bunch of information, look like a single DIO that's split in multiple messages. So that's also part of what we want to achieve here. And to do that, we have added a DIO sequence counter, basically. And not per option, it's basically the sequence of the DIO. If you sequence the DIO, then you can do 2 things. The first thing is, if I need to split this thing in 3 DIO messages, then they will have the same sequence. And the second thing is, if I want to refer to when the configuration option was changed for the last time, for instance, I can say, hey, it was changed with configuration state sequence block. So if this node has the DIO configuration option, the Ripple configuration option associated to an earlier state sequence, then it knows that it needs to pull the most recent configuration from the part. That's the core of what we want to do. So we have added this state sequence, and we have a new abbreviated option. So you have two O's, and there is a reason. It's an option, and it tells you that it's abbreviating another option. So basically, this is a very small vector which says which option it's abbreviating, and basically the only thing it does is give you the last RCSS, the last sequence, when this particular option was updated. So instead of putting the full option, if it was not changed since the previous RCSS, you can just say, here is this AOO, which is a replacement. If it matches what the node that received the DIO knows as the most recent state for this option, then the node knows that it's up to date. If it doesn't match, then the node needs to pull. I have also, I needed to change the base objects as we want. Do that. So I had to change the DIO to put its own sequence. There was also this discussion with Raoul in part for the DAO messages, right? We keep sending DAO over and over with the full information. Same thing, a DAO could be abbreviated if you send the exact same list of hosts as before. Then you could abbreviate them. So there's also an abbreviated version of DAO. And since now we turn the this into a query message, please give me the latest option blah, then there needed to be also something changed in the this base object, basically flags indicating which option is being queried. Next. So as I said, there are actually 5 options which are considered in this draft, and there's the global capability, the MOPEX, the PIO, the .DAC configuration, so report configuration option, and the route information option, which is basically how you know particular more specific routes this particular route can reach. So if you have to select a DAC based on where it can actually reach on the outside, then that's the route information option. So all of them are information that are useful to the node, that should quote unquote be repeated on every DIO, but the prefix of or the external routes can be reached through the route. They don't tend to change a lot. So once the network has settled, there is really no point to expose them, but unless there is a new node or something, a node that does not know them. So we enable to say, hey, they exist, here is the last sequence for them. And if a particular node is missing them, then it can go and ask through the disk. Next. And here is this AOO option. As I said, what it mostly says is, oh, I'm a replacement for option blah. So option blah being this the third box 3 here, a bribe option. So it's just one of those 5 options we just show. And the byte after that is the sequence number when it was last changed. Next.
1 minute, Pascal. Sorry.
And pretty much there. So this is the change in the disk to request the particular option. So you get the 4 option plus don't remember what that is, but basically that's what it says. It tells basically to the child tells the parent, hey, I want those options, and for those options here is the last thing I know about them. And there are more details. So if I have just 1 minute, I can go through that, but that's a summary of how the RCSS operation works. Implemented by the root, lollipop, or the usual. And also, it can be an information. It's not completely definite information, but it can be an information that helps the node to know that the root. By the way, that was another question by Raoul. There is the other slide that explains you what's happening. So if a child wants to resynchronize, then it can use those 5 bits and indicate, what it knows and what the latest it knows. And then the parent can see, oh, this has changed. Let me give it to him. This has not changed. Let me give him the abbreviated option. And that's it.
Thank you very much. Thank you very much, Pascal. Questions?
To the group, I mean, are people interested in? I did that work based on a request by the group. So do I get support to move on? Are you willing to discuss on the list now, later?
Sure.
Pascal, is George here? Georgios?
Yes.
The same question that I had before, actually, whether do you think it will be like two different solutions, or do you think it will be wise to include the DIS modifications inside this and go with one solution?
So actually, the reason why Dominic is on this is that the original point was to merge. That's why we were 4 bits for 5 bits for, I'm not sure. Well, the original idea was to merge. I have no clue if it's better or not. They need to be consistent, that's for sure. So at least shipping them together at the same time and keeping them, well synchronized, that's important.
Right. Exactly. We could have one that focuses on eliding DIO and sequence numbers and stuff, and have one focus on the new DIS semantic and format. But at least we want them to be consistent. Or we could do just one big draft, but it's usually a bit more difficult to handle. I have no strong opinion on this, as long as they work together.
As long as we are not trying to put a fragmentation and a compression on the same document, I guess.
I don't know what you're talking about.
Okay.
Any strong opinion on that by anybody in the group? Recommendations? Maybe Alvaro?
I think that we were right to kind of let this work coast for a bit. I think that we need to probably I think we need to probably let some of this stuff coast a little bit further until we get the rest of the documents pushed on a bit. And the reason is not so much just because we need to get it. We have only so many cycles, but I think that we need to get some experience from the stuff that we've done, all of the role and the use of RPL and the capabilities stuff. I think we need to get some cycle of feedback from implementers to continue before we can step onto this part for that. And as I wrote in the chat earlier, half hour ago, I think we're getting very close to 6550 BIS thinking. And I think that this kind of thing actually may be what pushes us in over the hill into saying, okay, this is really just a new mop, and we need to do this that way.
Okay.
Okay, thank you.
But definitely we want to take this use case into consideration for these modifications. I think we have the need clearly expressed.
I did not hear what you said, Dominic. Sorry, can you repeat?
Yeah, I was just saying, at least we have the need for a modification in DI. It's clearly identified. The way the solution is engineered for eliding DIO is probably maybe not fully cast in Aaron, but at least we know we want to do something with DIS to address that need. So we can, on our side, we can start working on DIS modifications, taking that use case into account.
Thank you. So, one question: do you want to have another meeting at the end of May, like 2 hours meeting, to
Yes,
keep working?
definitely.
Okay.
Yes.
Yeah. So we will organize. Thank you very much. So next steps is we are going to send a summary of this meeting with the action points and the link with the recording. So, and if someone have further questions, we are here. So I think we can conclude the meeting. We are 4 minutes above the limits. So, but thank you very much for today and for the conversations. We keep in the mailing list until the next meeting. It's okay for you 2 hours, right? Or 2.5? I think 2 hours is fine. So we don't get too exhausted.
Start with 2. We can still have another interim meeting if you want to.
Okay, so now I will stop the recording.
better to have a couple of meetings of less time more frequently than
Yeah, yeah,
the ones that are harder to survive.
I
Right.
agree. Okay, stopping the recording.
Thank you for so much.